All right, here's 1.6 day 2, still working with quadratics. Shifting gears to a technique known as completing the square. Does some similar things to factoring, mainly solving quadratic expressions. But I want to start with a quick discussion as to why completing the square is necessary. Okay, we have a quadratic here, y equals x squared minus 4x plus 10, and our instructions are to factor. All right, so I'm going to take a look at this here and see. All right, I've got 10. I notice there's no number in front of x squared, so this means that a is 1. So factors of 10. The middle term is negative, so I'm looking for one of each. Okay, those don't add up to negative 4. Those don't. Those don't. And those don't. Okay, it's got 4 different sets of factors. None of them do the job as far as adding up to negative 4. Okay, this is the point I'm making here, which you've probably already figured out. Factoring is nice, it's quick, it's efficient, but it doesn't always work. Okay, it doesn't always work. We have to have, if we want to solve a quadratic function, we have to have some other techniques to go to that are more reliable. Okay? Hence, a lesson on completing the square. All right? Here's a set of steps, all right, that you can go to that typically work quite nicely to complete the square. All right? same equation here. Okay? You'll see step number 1. I'm just going to kind of go side by side with these steps here. Step number 1. Set it equal to 0, which was technically also true when we'd factor. You know, when we're solving quadratics, they're easier to solve when they're set equal to 0, and that also gives us x-intercepts. So it's very commonly what we set it equal to when we're solving. Our c term, which here is 10. Okay, move it over. I subtracted 10 from both sides, and I get an expression that looks like this. All that's been done so far is set it equal to 0 and subtracted 10 from both sides. Okay? Now I did that because, remember, when I looked at factoring this, 10 didn't work. So I want this to end in a different number. Okay? One that's going to work nicely. Okay, as far as factoring the right side. Okay, and what I do, it's kind of a strange little step. I'm going to put it down here at the bottom, but you take, b, which is your middle term, you divide it by 2, okay, which is negative 2, and then you take negative 2 and you square it, and you get 4. Okay, I am going to, instead of adding 10 here, I am going to add 4. Now, I can't just do that and switch the last number to 4. I can make that work if I abide by the rule that if I do something to one side of the equation, I have to do it to the other. Okay, so I'm going to tag on this plus 4 on the right side. I'm also going to tag on plus 4 over on the left side. Okay? What this leaves me with here is negative 6 equals x squared minus 4x plus 4. Now you might be thinking, random. Kind of a strange step to make. Okay? And up to this point, it would appear so that that's a strange thing to take that middle term, divide by 2, and then square it. The reason I did that is because when I look back at this right side, I'd actually kind of want to get back to the concept of factoring. And remember, plus 10 at the end didn't work. Plus 4 is going to work beautifully. Okay? 2 factors of 4 that add up to -4? Well, that would be -2. This would have 2 of the exact same factor. That's not a coincidence that that happened. When I did this, I set up this step here in red. Okay? I chose a number that this was going to factor really nice. And now what I can do is I can write the right side as x minus 2 squared. Okay? This step right here, where I put in that +4 that I found down here, I add that 4, okay, and I technically complete the expression by making it a perfect square trinomial. It's this step right here. This is where the technique gets the name completing the square, is you add this third term to your expression that makes it factor beautifully into 2 identical factors, okay? That's why I did it, all right? And it will always work out that way if you do this piece right here. It'll always work out, okay? It says solve if necessary. There's a couple different routes that I could go here. One of which would be I could add 6 to both sides. Okay. This is the same equation. It's now written in vertex form. When I go through the next example here, I'll go through one as to how you could solve it. Okay, some could just ask for the equation, others could ask you to solve. All right, here's another one. Now it says solve for x by completing the square. Okay, I mean, if you want, yeah, and I should mention this more often, that if this is a point where you want to pause, try this problem, and then resume with me to see if you got it. I mean, if you're feeling confident after that first example, that's a great idea. If not, let's work this one through together. Step number 1, set that quadratic equal to 0. Step number 2, take your constant term and move it over to the left side, which I did by adding 4. Okay? Now you could have, I should technically, the very first step should be to try to factor it, but given this is an example where your instructions are to complete the square, that's a pretty good indication that it's not factorable, and it's not. Okay? This is the step where we complete the square. I've got this blank little spot right here where I want to add a third constant term, but I want to do it so it factors like a perfect square trinomial. Okay? Remember, trinomial is just a fancy term for an expression that has 3 terms. Okay? Right now I have 2. I have x squared and 7x. So I do that same step that I take 7 divided by 2 and I square it. And I get 49 over 9. Okay? 49 over 9. So now I'm going to tag that on at the end, which is totally not legit as far as an algebraic step if I don't do the exact same thing over on the other side. Okay? Have to do that. And in fact, while I'm over here, I'm going to take 4, and don't you dare, go fraction phobic on me. We can deal with fractions. I'm just going to change the 4 to 16 over 4. And in fact, I'm going to move along here to this next step and see that those add up to 65 over 4. And over here, okay, remember the factor itself is going to be this, 7 over 2. This one's a little bit different because it's got the fraction thing going on. I mean, it's really not, but it's not as intuitive as to factor that, but this will be written as x plus 7 over 2 squared. Okay, and this is kind of where I stopped on the other one. What I could do now, all right, and this is where it works beautifully. Okay, I've said that many times. If you're into algebra, completing the square is like art. It's beautiful the way it works out. It's just fantastic algebra. Okay, I don't know if you've had a teacher describe algebra that way, but it's like painting a picture. It's fantastic. Okay, now I can take the square root over here and leave myself with x plus 7 over 2. And remember, the square root on the left side applies to the top and on the bottom. So the square root of 4 is 2, and we get the square root of 65 over 2. Okay? I'm running out of room here. I'm going to have to go down to this little white space here. There's only one step that's left. I'm going to subtract 7 over 2 from both sides. Okay, that cancels. And what I'm left with here is, on the left side, well, I should add right here, anytime I take a square root, I have two possible solutions. Plus, or positive square root 65 over 2, or negative square root 65 over 2. I need to take that quantity, and this is all over one fraction, minus 7 over 2. Okay, and there would be my solutions. Okay, a challenging technique without a doubt. That's something that I think is good to just be straightforward about. Completing the square is a little bit challenging. However, but you can see what it does. It allowed us to solve a quadratic that was not factorable. Okay, and without this technique, if we wanted to solve that quadratic, we would just simply be stuck. We'd have nothing to do. All right. Let's take a look. Now that's an awful lot to think about for one lesson. All right. I do want to just touch on this one. Okay. You can see the difference here that A is bigger than 1. Okay. Go with a really simple strategy. Divide everything by 6, and then when you set it equal to 0, do x squared plus 2x minus a half, and don't you dare be scared of that fraction. Yes, the c is 1/2. It's fine, okay? The next step would still be to take the c term, move it over here. This is the step where we take 2, divide it by 2, we'd complete the square over here, blah, 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 okay? If you want to take a look at that one. The one thing I will say, if we're going to write it, for solutions, we're fine to keep going. If we wanted to write this in vertex form, we would have to kind of make note, we're not done with that 6. That comes back into play at the very end. If you want to do what we did in the previous example up here, just proceed and follow the steps, okay? We can ignore the 6. But if we wanted to write the equation in vertex form, we got to factor that 6 in. Okay? Just to keep you going here, the term that this is going to end in, if you were curious, is plus 1. This whole thing over here factors to x plus 1 squared. Now I can solve by taking the square root of both sides. Okay? That is, whoops, excuse me. Skipped one little step here. Almost made a huge no-no. I didn't add, okay, when I added the 1 over here, I need to add it over here as well. All that changes is the fact that now on the left side I have 3/2, okay, instead of 1/2. Take the square root of both sides and proceed to solve. Okay, that's completing the square. As far as questions go, I would imagine there is some. Make note of those, and certainly, let's talk more.